Here's a little demonstration of how sine and cosine work in the unit circle for general angles. I wrote this with Geometer Sketchpad version 4. If you've got Sketchpad version 4, I put the sketch itself on the CD or on the website so that you could load it and play with it yourself. But just let me show you this demonstration. What happens is the angle that we're interested in goes with the angle in standard position. Here is the initial side. Here is the terminal side. So the angle is measured here. This would be the angle theta, and it's reported down here. Notice that it's given as a multiple of pi radians, so it's in radian measure. What we know from this last lecture is that the point on the unit circle, whose coordinates are specified here, is the point where the x-coordinate measures this distance out. This horizontal distance is, on the unit circle, the cosine of the angle, and the y-coordinate, this number is this distance, it's the sine of the angle. So let's play with this, moving the angle around and watching the coordinates change at the top, watching the angle size change at the bottom, and see what's happening. Let's go down and verify first of all something we did a lecture or so ago, that cosine of 0 is 1 and sine of 0 is 0. With the angle there, that's what happens. The coordinates of the point on the unit circle, 1, 0, give that fact. Now we'll let it go up and around. We watch what happens as the angle gets bigger. The first coordinate's getting smaller, cosine's decreasing, and sine is increasing, till when we get to 90 degrees, which is pi over 2 radians, 0.50 pi radians in this decimal notation. The cosine is 0 and the sine is 1. Now we'll go on around and look at an angle in quadrant 2. Moving over to an angle in quadrant 2, a point in quadrant 2 has its x-coordinate negative and the y-coordinate positive. That means the cosine is negative and the sine is positive. On around till we approach pi radians. We could also look at what's going on in quadrants 4. Now we're going backwards. We're making the angle open clockwise, so we're measuring the angle in a negative direction. In quadrant 4, the red line is going down, so it's negative. The blue line is positive. That means cosine is positive and sine is negative in quadrant 4. And on around in quadrant 3, both the red line and the blue line are negative. The blue line is going backwards, the red line is going down. Notice the coordinates of the point are negative, so both sine and cosine are negative in quadrant 3. Now, the other point that we made in the lecture was that you could keep track of the symmetry of the trig functions by studying the unit circle. Let's go to a point in quadrant 1 to make that happen. Let's make the angle something decent. Mine is 0.15 pi radians. Notice the value of the x and y coordinates of the point on the circle, so 0.89, 0.46. Now let's go down to minus 0.15 radians. 0.89 and minus 0.46. What's happened is the x-coordinate stayed unchanged. The y-coordinate went from positive to negative. For the negative angle, the y-coordinate's negative in quadrant 4. For the positive angle, the y-coordinate is positive in quadrant 1. So what's happened is, since the y-coordinate is related to the sine of the angle, negative angle changed it to a negative value of the sine function. Positive angle, putting it in quadrant 1, or it was about here, putting it in quadrant 1 made the angle positive. And for the x-coordinate, the cosine, it didn't matter. That blue line looks the same in quadrant 1. It's going out the same distance in the same direction as when I draw the angle in quadrant 4. So that the blue line measuring the cosine function doesn't change sign when you go from a positive angle to a negative angle. The significance of that is that the cosine function is an even function. Well, give this a try yourself and play with the values. It helps to drag it around yourself if you've got access to Sketchpad. I can also save it as just an HTML page, but I'm afraid I'll miss some of the detail, and it's pretty to see it with the graphing option that Sketchpad 4 provides. So give that a try.